Right, this is just a little help video for this lesson's work. So you should have got through the idea of what an ion is, that it's a charged particle formed by the gain or loss of electrons. And then if you've understood this well enough, then you can see, you've been through all of these, that you end up with a summary. And on this spinal sheet we've got that metals form positive ions, and they'll form a positive ion because they are less negative, and that means they've lost electrons. Non-metals form negative ions, and that means that they've gained electrons, and this is because electrons are negative. And that some of the compound ions that we need to know, most of them are negative, the ones that we need to know. And if you're not sure what the compound ion was, you go back to this sheet, and you can see on here we've got the compound ions here. So it said some ions are actually made of groups of atoms called compound ions, and these we just have to learn. So you should have done your look, cover, write check on there. So ammonium, hydroxide, nitrate, carbonate and sulfate. All of this together means that we're able then to work out the formula of particular compounds. Only ionic compounds, and they're ones that are formed by ionic bonding, and ionic bonding is something you'll probably do next. So I've given you a few examples, hopefully my banana example made sense, but basically this is saying that if we want to work out what the formula of sodium chloride are, the way we go about it is we'd look on the periodic table of the elements if we didn't know anything about sodium or chlorine, and I'd find on my periodic table that sodium has the formula, not the formula, sorry, the symbol Na. And I'd also see that sodium was in group 1. So you need your periodic table. You've got one in your homework diary if you can't find one in a chemistry book. So sodium is in group 1. Now sodium is a metal. I know that because it's on the left hand side of the periodic table. So my periodic table, I see sodium as a metal, it's in group 1. That means it says metal ion. I'm going to write the symbol of sodium here, and because it's in group 1, I've learned previously that means that they will form an ion which is just a plus, so that means +1. And it's a plus because it's a metal over the left of the periodic table, and it's just 1 plus, no number, because it's in group 1. I do the same for chlorine. Chloride, I know that is to do with chlorine. I look on my periodic table of the elements and I see that chlorine forms a minus ion, and I know that simply because it's in group 7. Now, because it's in group 7, I might not really understand what that means. I see it on the periodic table that it's in group 7, but I might have to look back at this. And I'll find this, and it says, here we are, so we've got the group number. I see chlorine, it's in group 7. This means there are 7 electrons in the outer shell. And that means in order to make our magic number, our stable number of 8 in the outer shell, then we need to add 1. And if we add something that is negative, it becomes negative. So we're going to add an electron, add one more negative thing because electrons are negatively charged. That means the ion that's formed we call Cl minus, one little minus there. So I'm going to take that's the ion that's formed, and I'm going to put it in this table, and that's why I've written here Cl minus. Now if I want to know what the formula of sodium chloride is, then I can work it out. And the idea is that these charges balance each other. They have to cancel each other out, in other words, because the compound itself does not have a charge. So if I've got 1 plus and 1 minus, we know that they are going to balance each other out, cancel each other out, and you end up with a 0. So it says there's 1 plus and 1 minus, so they cancel each other out to 0. That means they must be in a ratio of 1 to 1. So my formula is Na, just one of those, and Cl, one of those. To talk about this next example with magnesium chloride, You might think, well, I would have put NaCl anyway because it's sodium and chlorine, but how would I know whether to put a little number here? So let's look at this example for magnesium chloride. Exactly the same. I'd look at my periodic table of the elements and I'd think about what is magnesium. Well, magnesium is Mg. I look it up in my periodic table. I see it's over the left-hand side. Left-hand side means that it's a metal. And I see that it's got a symbol of Mg, and it's in group 2. Now, because it's in group 2, I know then that they form a 2+ ion. And that's because, if I'm a bit confused about where that's come from, I can look back to this sheet. I can find something in group 2. So here I've got 2 things in group 2. Magnesium is in group 2, and calcium is in group 2. That means they've got 2 electrons in their outer shell. That means it's much easier for them to just ditch those 2 electrons, and then the outer shell is 8 previous to that. So if we were not sure, we could write out the electron configuration. But as a sort of shortcut, all we need to do is we need to say that magnesium is in group 2. That means there's 2 electrons in the outer shell. If they get rid of those 2 electrons, they are less negative because electrons are negative, so we say we've got 2 positive, positive just being less negative. So that's the ion formed. If we can't remember it, we can just look back at this table. But I can remember that because it's a plus because it's a metal, and it's 2+ because it's in group 2. That's simply how I would remember it. We go back to here then, and that's why I've written the metal ion for magnesium is Mg2+. Chlorine, the same as before. I look it up in the periodic table. I see that it's in group 7, it's Cl. Because it's in group 7, I know that it's going to form, well, maybe I can't remember, so I'll have a little look back. Okay, there we go. Anything in group 7 has 7 electrons in their outer shell. That means in order to become stable, they like to gain 1, and that means the ion formed is Cl-, just 1-. That means gaining 1 electron. This here, Cl-, I'm going to put into what the non-metal ion was, Cl-. So perhaps I might guess that the formula of magnesium chloride is say just MgCl, because it's got a magnesium, it's got a chlorine. I can check to see if that's correct by looking at the ions. I can see, so I've written here, there are 2 positives and 1 negative. There's our 1 negative. So to balance out, we need another negative. This means I've got 2 positives, I've got 1 negative. If I had 2 of those, that would equal 0. So 2 positives add 2 negatives, that equals 0. So that means for every 1 magnesium ion, there must be 2 chlorine ions. So we end up with our formula MgCl2. Just going to find a periodic table so I can show you a bit of a shortcut. Okay, here's the periodic table. So what I do when I'm trying to work these out is I have a look at the periodic table, and I know that everything over the left is going to be, so there's like a little step here, or some periodic tables that are separating the metals from the non-metals. Metals have a small amount of electrons in their outer shell, so group 1 will have 1 electron in their outer shell. So I start here and I say anything group 1 is going to lose 1 electron. Anything in group 2 is going to lose 2 electrons. Anything in group 3 is going to lose 3 electrons. And we can sort of start going, we ignore the noble gases at the end because they're unreactive. We can sort of start going back in. So our group 7, they want to gain 1 electron. Our group 6, they want to gain 2 electrons. And our group 5, they want to gain 3 electrons. So we're sort of counting back. On a sort of basic level, this number of electrons that either are either lost or gained, sometimes it was called combining power. So we can think, if you want a little bit of a shortcut of how to do it, if we had, say, magnesium chloride, and we know that we want to work out what the formula of magnesium chloride is, whether it is just that or if we have to put any stupid numbers in. Well, I look on my periodic table, I see that magnesium is in group 2. So I'm gonna that means it's got a combining power of 2. I look in my periodic table, I see that chlorine is in group 7. That means it's got a combining power of 1, and we're almost doing a count back. So we say 1, 2, 3. So we're counting back from each side to the middle. 1, 2, 3. If we can remember that, 1, 2, 3, we can work out most ionic compounds. Not all of them. They're not all. You're not able to do that shortcut for all of them. So we remember again, 1, 2, 3. We're ignoring that. So I look for magnesium. It's in group 2, so I've put a little 2 here. Oops. I look for chlorine. I see chlorine is in group 7. Remember, we were counting back. 1, 2, 3. So I've put a little 1 there. There's a little 1 here. And this is really just about ratios. So the shortcut is you can cross them over. What does that mean? Well, that means I'm continuing with 1 magnesium and I've got 2 chlorine. It works. If the other way is not making any sense to you yet, it's a little shortcut. I'm going to try this way on a more complicated one. So one of the ones is, let's say, magnesium nitrate. Okay, magnesium nitrate. I might not remember what nitrate is, so I find it on here. There's nitrate, NO3 minus. NO3 minus. So that means it's got a combining power of 1. Magnesium, it's just 1 because there wasn't anything else written there. Magnesium has a combining power of how many? Well, it was in group 2, so we write 2. We cross those over. That means we have to have 1 magnesium. And then we need 2 of these. And if we've got a weird compound like that, then we have to put that into a bracket. 2 of those. Have another go. I'll see you on chat if you're stuck.